Hello there. Guess who? Welcome back. It's me, Al, with another idea for something to do that might interest someone in the world. Alan Carr Inc. Oh yeah. And what I was thinking of doing was I went back and looking at one of the very first programs that we made when doing learning about just Windows programming in general, and that project. I ran into a lot of trouble over this one. It was called Window. Okay, well, this one was not one that liked being renamed to something else. Everything that said window turned into something else. But anyway, this window thing. I don't know if you probably, anyone watching this probably doesn't recall, but I built it, and believe it or not, it still runs. Here it is. And this was essentially what it did. You clicked and it would print out a little message. That disappeared and the client wrecked. And so we got an idea how to make a window. And this one is also, turns out it's resizable, and a bunch of other nifty little things, and changing the cursor picture and so on. So that's a basic window to begin with. And what I like to do is, and you might be able to guess by the project name. Well, first off, what I'd like to be able to do is make a window a bit bigger than that other one. This is the same project almost, but I made a few changes to it, trying to remember how these things work, like my div class and TSD context and all that. A bigger window, not resizable. What I'd like to be able to do first off is to be able to draw, to first take any given data set, let's say some numbers printed out in a text file, floating point numbers, and to plot them on a graph. So to decide on the basis of the numbers, how the X range and Y range, let's say, if we have a collection of points, X and Y, and to draw a curve through those points eventually. But first I'd like to be able to solve the problem of taking an arbitrary collection of numbers and to draw a graph that nearly fills the entire rectangle of the window. Now, what I've done with that old one here, and what I changed, is instead of what it was before, I can put that in here, I suppose. The window thing, before we knew anything, before we knew any better of what we were doing, was what you would expect to do. When a WM Paint message came along, we would draw the entire area of the screen. And here it's being done like this. I'm not drawing the cursor position, I just added that. And that's fine, and that worked well for that. But what I'd like to do now, what I've done in this one, is instead of drawing to the screen, I like to draw into a memory device context, and then on a WM Paint, you split that to the screen if necessary. An example here I've just done as an example, mouse move. Okay, now I worked out these coordinates by printing it out, printing the whole screen and the mouse position, and finding out the coordinates where these numbers change, the top left and bottom right corners. And then what I'm doing is drawing rectangle here, draws a regular background color in that rectangle, and then I'm outputting this string here at that position. Actually, I've got this cursor paused now. Oh no, wrong. I'm doing the wrong thing. I have cursor paused twice. I guess I don't need this. Should work just as well, I think. Maybe not right off. Oh no, but I'm not invalidating that part. Well, we'll see what happens. And then I'm just invalidating what a part that I made a mess of, and then on WM Paint, this clip blit only blits the part that I've invalidated. Let's see, it's not redrawing that part. Now it could. All I have to do is change this rectangle. Let's see. Let's say 191 for the left. Just 190. Just 191, right? Yeah. Yeah, 191 here. Top is right. Yeah, that should be it. Just the left needs to go further. 190 maybe was correct. Now that's an example. A thing like this, right, which only draws itself, is an example of a kind of like a control. This is essentially a text control that draws itself and knows its own size, and one could make a structure out of that has, maybe has a rectangle member, and draws just itself to the memory device context and invalidates its own rectangle. Now, if an object like that moves, then that's a bit more complicated. You would have to, I suppose, you would have to draw a rectangle where it currently is, and then move to your new position, and then repeat the whole thing again. That would have the effect of erasing the old and replacing with the new. But then you would have a sprite, what they call a sprite, something that moves around on the screen and doesn't consume a lot of processor time, or more importantly, graphics time, because only a small part of the screen is actually being drawn. This blit here only draws, as you saw, the dirty rectangle. Now, that's not so important. What's more important is taking the data and drawing the coordinate axes first, trying to work out that problem, and then plotting the points. So I could draw some dots, and then there's the problem of trying to draw. Well, at first we can just use the line to method. Windows comes with something called line to. So if we go from one point to another, it'll draw a line from one point to another. But in the end, I thought, because you may have noticed from this name, or maybe you don't know anything about it, there's a branch of computing and mathematics together, which has to do with what we call a curve interpolation. And the name Hermite, the mathematician, comes up because of these four functions that I've drawn here. These are called the Hermite basis functions, cubic Hermite basis functions. And they're used in computer graphics and games and so on and so forth for drawing smooth curves through just a few points. Now, how that all works, the theory, I'll try to explain to you next time. But it turns out that just with these four functions, right? Always S here goes from 0 to 1 in each case. You can draw a very nice smooth curve through almost any set of points, and they don't have, the points themselves don't have to form a function that is, in the strict sense of the term function, a function f of x would not contain any loops or anything. A circle, for instance, is not a function. An arc is a function, but a function is a single valued thing. For every x, there's one and only one y. But with these things, and using a parametric form of function, that is a function which uses a parameter like this s here, which maps from that single value at a point somewhere in the x and y plane. And these functions are used to do that. And you can do that you can use this to draw a curve, and that's part of the story. And then another part of the story is motion along such a curve, making it smooth. Like how do you figure out the speed that a thing would move along? Generally speaking, these curves are related to this s in such a way that equal intervals of s do not correspond to equal intervals along the curve. It would speed up and slow down and so forth. But anyway, this is the theory part that I'll get to at some point. In fact, I have an excellent page. I'm not going to give it to you just yet because I don't want to jump the gun. I'd like to get the basics working first. Drawing the coordinate axis, just drawing any function like y equals x squared, just with using line 2, with our pen. We have a pen. This project has a pen. It's white, I think. Or do I have a pen? I have a pen. Well, it's no initially, and it changes the set text color. Okay, so we have no pen, but we'll make a pen. And with a pen, you can draw dots and lines and so on. So that's my plan. Maybe I'll just upload this as a preamble as I try to work out some more of the details of what we want. I wasn't really joking when I said that this is like a text control. I would like to be able to define a class or structure to do with drawing text. Like not editing it, just drawing it. And that would have a rectangle and text. And it would have a function called draw. Let's suppose a good starting point might be to have some kind of pure virtual base class, and for any kinds of objects we want to draw, we would call the virtual draw function, and well, let's say an object would have a rectangle associated with it. Maybe it doesn't, but it's probably easier to think of it that way. Then it would be once we have a little text control, then we can put labels, you see, on the various axes and put a title or whatnot, and it'll be easy because we can just add these controls to a list of things that we may update, every once in a while, in case they change, like this cursor moving around. And then the graph itself, which I guess could be another form of that type of control object, if you like. Okay, so that's the plan. I'm going to show you first what these Hermite curves are, and then go on to talking about another thing called a spline, which you may have heard of. But just with I guess the category of what these interpolated curves are called splines, and there are various types of splines, and they have funny names, named after the people that work on them or invented them or whatnot. So okay, well, that's a heads up, and there's nothing to look at yet. There'll be something to look at next time. And yourself, if you want to play along, you can always send me a message, and I'll send you the code as it's being developed. Okay, see you.